And let's take a look now at number 4. So I'm going to go over to number 4. Number 4. This is also 64. This is 64% here. 64%. It says this: the graph of a piecewise function is defined is shown. A piecewise defined function is shown. And there's the graph. And we want to know which equation accurately describes this graph. So I want to let you know before I go to Desmos how these work with the symbols. A closed dot. Let's just talk about this first. A closed dot. Does that mean you can be equal to the number or not equal to the number? It's a closed dot. Okay, let me change it. What if it was an open circle? Does that mean you can be equal to or not equal to? I'm asking a question. Is that can you be equal to it or not equal to it if you see an open circle?
Not equal.
Not equal. What about a closed circle? Equal. Okay, so the way these work is this is saying at the x value, I'm going to show you here first without graphing, and then I'll show you by graphing. This is an x value in -1. At -1, this first piece can be equal to, but the second piece cannot be equal to. So the first piece, when you look on these restrictions, you should be able to be equal to it. You see how this one says equal to -1? This one says not equal to. So that one would be wrong because you can be equal to it. This one is also wrong. It says cannot be equal to. So it's either B or D. And you could go through piece by piece. The second one should be less than an equal to on the second. So less than and then an equal to. So that's okay. That one looks okay. And then finally, the third piece, again, cannot be equal to it. So it's going to be B or D. And so we'll graph these to help us out. Now remember, piecewise for Desmos, you don't actually graph in the front f of x and then the squiggly. Rather, you put the squiggly after the fact like this. Now I'm going to go ahead and tell you the answer is going to be B. And how I know it's going to be B is your inequalities. You're only allowed to have one that opens to the left. All the others have to open to the right. You don't have to have any open to the left, but you're at maximum allowed only one opening to the left. So the answer is going to be B because D, they have a whole bunch opening to the left. You can't do that. So it's going to be B. But let me just show you how you graph that anyways. When you come over here, you would type each one of these in as its own individual equation. So x plus 2 quantity squared, or negative x plus 2 quantity squared plus 4. And to get that restriction, you do a squiggly, and it's x is less than or equal to -1. X is less than or equal to -1. And so what that will do when I look at my graph is that'll make it a closed dot right there. Now, if I had done a less than, it would have been an open circle. That would have been an open circle, but it's supposed to be a closed. So that's why it's an equal to line there. And then you would graph the second part of the equation, which just said 4. -1 is less than x, which is less than or equal to 2. So -1 is less than x, which is less than or equal to 2. That should give us an open circle on the left side, but a closed circle on the right, like our picture. And then finally, the last equation, 2x minus 5, squiggly when x is greater than or equal to 3. X is greater than, not greater than or equal to, just greater than 3. So now that I have that typed in, I'm going to change this over a little bit so you can see it. So you can see closed circle on the first piece, open and closed in that order on the second piece, and the third piece has an open there. And so that would be your graph right there. B would be the correct choice.